So we'll have a look at the weather in the weather situation above Europe. First of all, there is two troughs or cyclonic centers, one above northwest part near to Great Britain and part of Scandinavia, while the other one is far to the northeast. You can see a really nice system developing over Atlantic. It's a cyclone with a really nicely formed cold front and a warm shield. But most of the Europe is affected by a really strong ridge with strong warm advection from north of Africa, bringing really hot and dry air, which we can see by this kind of brownish color that's covering most of the Mediterranean and going further to east towards Turkey, while there is not as pronounced frontal system covering, let's say, from the ocean towards Spain and going up towards the Scandinavia. And you can see that this area is a bit even more moist than the rest of the Europe, because the color is more towards bluish and you can also see some clouds. If we now take a look at the cloud face RGB, you can see that there is stratiform clouds over Biscay Bay with quite big water droplets. There is also some small convection going over France, which is situated here because there is a jet stream going from, let's say, Great Britain and then towards up there towards Scandinavia. So there is like a little small dent in that jet stream, like a short wave that then causes lift and causes this convection. If we now have a look at the true color RGB, you can see that it's quite foggy. It's not clear as the other two. And the first thing that comes to your mind when you see such an image is either it's a lot of dust or a lot of smoke in the air. So let's have a look at the dust RGB. As you can see, there isn't much dust indication, a bit of pinkish color here and there, but that could also be a show of dry air, like for example here over the mountainous area over Italy. And if we now have a look at the air quality for dust in the model, you can see that the dust is really situated more over the Africa, and nothing comes to the central and eastern part of the continent. So our conclusion is it must be from the fires, which actually if we look at the fire radar power and put it over the true color RGB, you can see that some fires are quite active, and also the last couple of weeks were quite active with fires as well, since the dry season is already from the beginning of the year. Also, the heat wave season started quite early this year, from the second half of May. And then we had another intense heat wave in second part of June, which also had quite number of temperature records. Most affected region was the western part of Europe and also Mediterranean. And this kind of situation with heat waves, it gives more fine fuel for the fires and also drying up of the upper soil layer. The humidity is quite reduced, and also then the wildfires will spread faster. The preconditioning of this fire season was, as I said, the deficit of the precipitation that already persisted from 2025 in some of the regions of Europe, and also there was successive heat waves that occurred. The burned area so far is more than average 20-year average. And the most affected countries, as we could hear in the past few weeks, is Spain and France, where we also had quite large-scale evacuations because of the fires. So let's go on. To take a look at the fires, it's quite easy. You can use a Copernicus browser, which is a free online platform where you can access the data from your European Copernicus Earth Observation Program. And it offers near real-time, but also historic data that you can observe and manipulate a little bit. And it's also downloadable. So we are going to take a look at Spain, since it was quite fiery there. The center of Spain, Madrid, is here, so we are going to observe here a little bit to the west of Madrid. First, if you look at the true color, you can easily spot the plume of the fires, and also, let's say, the fire front. Also, if there are localized fires, you can see how they develop and how the plume goes into the atmosphere. And now if you compare from 4th of July and to the 26th of July, you can see not so pronounced, but you can see the scorched areas. They're kind of brownish. They're not as green as it was in 4th of July's, but you cannot really see like that good. So a better thing would be to use false color, which uses near infrared wavelengths. And then the healthy vegetation is red, while the burnt area are black, almost totally black, because the reflectance of near infrared is now gone. So it's not as in the healthy vegetation. Also, you can see that the plume from the fire is now more transparent, so you can see even more of the scorched areas. However, maybe the best product to use is SWIR, or shortwave infrared. It uses, it's highly sensitive to moisture content, so it's not just that you see the vegetation, also you can see how healthy it is. If it's darker, then it means there is less moisture in the plants than when it's really bright green, like here. And the plume here from the fires, it's even more transparent, so it's quite easy to use it and to make analysis of different fires, and also to see how strong the fire was and how with what force it affected the areas. So thank you for your attention. I will finish my presentation and Klara will continue.
Okay. So Kristina has already given us an overview of the current weather situation. And since the weather in Croatia is currently sunny and stable, I will take a look back at last week when the situation was quite different. Last week was quite changeable, with temperatures in Croatia even below average for this time of the year, especially in the continental part of the country. So we had a little bit of a break from the hot weather, mainly due to frequent unstable weather conditions that brought us some relief from the heat. So we will start by looking at this air mass RGB first to see synoptic situation. We were talking about last Sunday, so 26th of July. On this air mass, we can easily recognize some features, synoptic patterns in upper level atmosphere. We can recognize where is warm and cold air mass, and as we can see, some cloudiness in the southern France and northern Italy, which is connected to the trough, and eastern parts of southeastern parts of Europe are under the ridge, also as the this Atlantic part. If we put geopotential height on this image, we can see that we are right when we are looking at air mass RGB. Already in this night, some convections was going on in the leading edge of the trough above Corsica, near Corsica Island, and Croatia was under the ridge. But we can also see that from the west this trough was approaching, and that we can also have unstable Sunday in Croatia. What else we can see among ridges and troughs? We can also see the jet stream. These brownish colors on the air mass indicates the jet stream, which is also approaching from the west to the east. And of course, the greenish color is more warmer air mass, and the bluish color is more cooler air mass. To see the analyze, so the ridge was present over the Croatia during the Saturday, but the trough was approaching. Also on this map, we can see the wind at 300 hectopascal pressure level, which indicates also the jet stream. And if we look at the surface pressure, we have some low pressure system above Sardinia and Corsica, which was also approaching to the east near Croatia. So now we will take a look at MTG cloud phase RGB later that day. We can see a well-developed system in the lower part of the image, but what is more interesting, it is what is happening in the circled area. So this product, cloud phase, is very useful for monitoring cloud development, especially convective clouds. First, what we can see on the satellite image is these small pink, pinkish dots. They indicate liquid water clouds with relative large droplets. So, for example, over here above the Alps, we have some cloudiness, and these are water clouds, but some small water clouds are developing over here, and they are turning their color first in the light yellow and then to the blue, light blue to dark blue. That means that we have that the clouds are developing vertically. So first we have water clouds, which and they are growing, and droplets become smaller, and that's why we have yellow color. And when they turn to light blue, then we have droplets turning to small ice crystals, and even if they grew even more in the atmosphere, they will grow into larger ice particles. And that's how we can recognize convective development on the cloud phase RGB. And this was happening during Sunday above Italy among Apennines. So, for example, this is well-development system, and here we have development which has just started. During the day over Italy, as I said, we saw continuous convective development of this kind. And this system produced heavy rainfall and also hail. I took this screenshot from European Severe Weather Database, which show us where we have some severe weather. So hail, these green triangles are representing hail reports, and these blue ones represent heavy rain. These blue dots were connected with the system before, but in the afternoon, this system produced hail over Italy, and this was the reports. For this example, the reported events were a little bit southwest of the storm on the satellite, which is normal, and we need to, when we are in a forecasting room, we need to be aware of the parallax when we look at the satellite images. The next image is another product. It's a sandwich product, so it's the same example, but just another product. The differences are because on the sandwich product, we can see the temperature of the cloud top, and this is the scale from blue to red. If we have more orange, more red cloud tops, that means that the cloud tops is even cooler and that the storm is more developed. These clouds continued to move towards the Adriatic Sea, but fortunately for us in Croatia, they weakened and dissipated as they approached the Croatian coast. For example, this system which caused hail over the Italy, when it comes over Adriatic, it is much weaker, and we can also see that the color is not reddish, it's just yellowish here. But more interesting on this image is this part at the south of the in the lowest part of this image, we have another system, and this one is really interesting because of the features, patterns that we see on this on the top of these clouds. For example, on this one, we have that red dot, which indicates that probably here we have overshooting top, and the storm is developing and the updraft is really strong. But on this one, among the overshooting top, we also have plume, and we see these wave patterns, which indicates gravity waves. So the intensity of this storm is probably high, and we can recognize it on the sandwich images, but also in the cloud face. We can recognize these patterns, overshooting tops, plumes, waves, but also interesting thing on this one is the shadow. So the cloud, you can see the shadow, this darker area on the picture is the shadow of the cloud, but also the shadow of the plum. One of the best new products from MTG is definitely a lighting imager, which we can overlay with every other satellite images. So the maximum lightning activity is around overshooting tops, and this is how we can recognize the core of the storm, the updraft, and where we can expect most hazardous weather. So as I said, many of this storm weakened as they approached the Croatian coast, but in the late evening and during the night, another system developed. This system was more connected to another trough which was approaching from northwest, and the first trough that we saw on Air Mass RGB goes more to the south east, but as I said, a new trough approach from northwest, and in mountainous region in Croatia, in Gorski Kotar, on orography, clouds starts to develop, and because satellite imagery is more limited during the night, we can monitor such systems using the enhanced infrared product. The color of the clouds indicates the temperature of the cloud tops, and the more red color we have, that means that the cloud is more developed vertically. And also in Croatia were reported some heavy rainfall in this part of Croatia, which are connected with this system. In Croatia, there wasn't any hail because the air which were approaching wasn't so much cooler than the air in Croatia, and the atmosphere was still too warm, and the profiles were more skinny cape we had. So these systems caused only heavy rainfall, and we can see how that looked on radar effectivity. Well, we had a really interesting weather in Croatia. So I said the storms were weakening, and we don't have any great impacts like hail or wind gusts or something during the day, but something really interesting happened in the island of Hvar. As you can see on the pictures, we had a meteotsunami. So the intense storm that I was mentioned were still intense above the sea, but not at the coast. And these events, such as meteotsunami, are actually quite rare. But this July, we had almost 4 or 5, I'm not sure exact number, but we have 4 meteotsunamis this July in Croatia. And they are caused by rapid changes in air pressure associated with intense storms over the sea. So you can see the location of the Hvar Island on this map, on this picture, but also you can see that we have some intense storm above the sea, and that's probably the reason why meteotsunami happened in Hvar. Of course, some locations, some islands are more prone to meteotsunamis than other, but they are really rare. But this July really happened quite often. For this example, I don't have automatic measurements, but as I said, we already had similar situation a week ago, a week before. On 15th July, we also had meteotsunami in island Malivoshin. And you can see on these automatic measurements of wind, temperature, and air pressure that we had that we have rapid rising of the pressure at the surface, and then a strong decreasing in the pressure, which caused the meteotsunami. Also, this one was connected with intense weather, which we can also see from this measurement. We also have a really rapid decrease in temperature, and also the gale force wind gusts were recorded at Malivoshin. So it was really interesting that we had this specific weather event this summer. And that's all for me. For now, we have a break from convection, and we are trying to enjoy this stable weather while also staying safe from the heat wave. If you have any questions, feel free to ask.